So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over the AS Maths June 2019 Paper 1 Section A. Now as always I'll include a question breakdown so you can see which question refers to which topic in this section. So let's get started on this Section A of June 2019 Paper 1 on the AS Maths paper. So looking at question 1, it says state the number of solutions to the equation of tan 4 theta equals 1 for theta is between 0 and 180. So for this, one thing I would recommend they do if you don't know the answer straight away is to potentially draw the tan graph, and it looks something like this between the region of 0 and 180. So this is 0, that's 90, and this is 180. So because it's 4 theta, we want to repeat this 4 times. So if I just draw a solid line there and then just continue that graph, I'll use a different colour just so it stands out. So that's 1. And now the green line doesn't represent the asymptote of the graph. It basically just represents every sort of range of 180 rather. So then here I've got this next one and slowly running out of colours. I've then got this. So this shows 4 regions of 180. Now if I then draw tan theta equals 1, so draw where it equals 1, I can see that for every one of these it's going to be a total of 4. So the one I need to circle is going to be the third option. Then moving on to question 2, it says Dan believes that for every positive integer of n, at least one of 2n minus 1 and 2n plus 1 is prime. Which value of n shown below is a counterexample of Dan's belief? You need to circle your answer. So again, what we could do is do 2n minus 1 and then do 2n plus 1. And if I just set this up for those 4 options, and if I then pick an n value, and we've got 3, 4, 5 and 6 to choose from. So let me just get rid of those like so. And then if I substitute the numbers in, so here I'm going to end up with 7 and 9. Here I'm going to end up with is 16 take away 1, which is 15 and 17. Then I'm going to end up with 31 and 33 and 63 and 65. So looking at the columns, 7 is prime, 17 is prime, 31 is prime, and so the correct answer is going to be n equals 6. Then moving on to question 3, it says it is given that x plus 1 and x minus 3 are 2 factors of f of x, where f of x equals px cubed minus 3x squared minus 8x plus q. Find the values of p and q. So taking each of these factors, so for this one we know that when f is minus 1, that f of x is going to equal 0, and we know that when f is equal to 3, it also equals 0. So substituting minus 1 into this expression here, we end up with p, and then we'd end up with minus 1 cubed minus 3 minus 1 squared minus 8 minus 1 plus q, and that equals 0. Then for the next one we've got p of 3 cubed minus 3 squared minus 8 3 plus q, and that also equals 0. Now doing a bit of simplifying, then what we find is that if I just put this as a 1 and this is a 2, so looking at number 1 we can see that that's going to be simplified to q minus p equals 5, or minus p plus q equals 5. And for 2, if I simplify all of that, I end up with 27 p plus q equals 51. So then treating this as a simultaneous equation, if I take those two I end up with 27p plus q equals 51 and minus p plus q equals 5. Now you can either use your calculator to solve this, or you can do it using the algebraic way. So here we're going to end up with 28p equals 56. So p equals 2, and therefore q would equal minus 3. Then moving on to question 3b, it says factorise fully. So here if I start by writing the original equation, so I've got 2, because we can now replace p with 2 and q with 3, so I end up with 2x cubed minus 3x squared minus 8x minus 3, and that equals the third term, which I don't know, so I'm just going to call that ax plus b, but we do know that the other two terms are x, if I just go back up the question, x plus 1 and x minus 3. So then if I expand these two things here out, I get x squared minus 2x minus 3, and I've got ax plus b. And so looking at this, we can see that, well, I need to get 2x cubed, so that means that a must equal 2, and to get my constant I need to multiply b by minus 3, so b is going to equal positive 1. So what I then end up with is my completed factorization of 2x plus 1 and then x plus 1 x minus 3, and there's my final answer. Then moving on to question 4, it says show that root 6 over root 3 minus root 2 can be expressed in the form of n root n plus n root m, where m and n are integers. Fully justify your answer. Now the reason why they're writing this is so that you don't just simply type it into your calculator and you get your final answer. So you need to make sure that you are using and showing correct steps in order to attain those 4 marks. So if I start off by writing the question, so I've got root 6 root 3 minus root 2. So first things first, let's rationalize the denominator. So to do that, I multiply by the denominator, reversing any sign that's in between. So it's going to be root 3 plus root 2. Then if I do that successfully, I end up with root 6, then root 3 plus root 2 over, and it's going to be a difference of 2 squares, so that's going to be root 9 minus root 4, which then gives me root 18 plus root 12 all over 3 take away 2, which leaves me with root 18 plus root 12. Then for this, what I then need to do is to simplify each of these. So root 18 is equal to root 9 times root 2, so that's going to be 3 root 2, and root 12 is equal to root 4 times root 3, which is 2 root 3. So then combining these two things here, I get my final answer of 3 root 2 plus 2 root 3, which is exactly how they wanted me to show the final answer. Then moving on to question 5, it says sketch the curve of y equals g of x, where g of x equals x plus 2 and x minus 1 squared. Now with this bit here, what we've got is we've got a repeated root. So if I start by drawing my x-axis, I'm going to have a root at x equals minus 2 and x equals positive 1. So if I just mark minus 2 and I mark 1, then I know that the y-axis is going to go somewhere here. And then drawing the curve, which I'm trying to use a colour, we should end up with a line that goes through 2 and loops around 1. And when labelling, we need to make sure that we label our axes. So we've got the x and y axis. And I can also label this point as being 2 multiplied by minus 1 squared, which is 2. And so there is my final sketch. It then says, hence solve g of x is less or equal to 1. So I'm looking for where the graph is equal to 1 or equal to 0. So that's going to be this region here and this point here. So the answer for B is going to be where x is less or equal to -2 or x equals 1. Then moving on to question 6AI, it says show that cos theta equals a half is one solution to the equation of 6 sine squared theta plus 5 cos theta equals 7. So for this, what I need to do is use some trig identities, try and get the equation so it's just has got causes. So that's going to be 6, and instead of writing sine squared theta, I'm going to write 1 minus cos squared theta plus 5 cos theta. I'm going to take the 7 over to the other side to equal 0. Then from this, expanding the brackets, I get 6 minus 6 cos squared theta plus 5 cos theta minus 7 equals 0. It then turns into a quadratic in which I've got 6 cos squared theta minus 5 cos theta, and it's going to be plus 1 equals 0. And then I can factorize this. Now again, you've got a choice. If you're not too comfortable in factorizing with regards to cos, then what you could do is let y equals cos theta, and then you end up with 6y squared minus 5y plus 1 equals 0. Now it does actually factorize. So what it does factorize to become is 2 cos theta minus 1 and 3 cos theta minus 1 equals 0. So here we've got cos theta equals a half and cos theta equals a third. Then from this we can then say, and again if you wanted to use your calculator and use the equation solver, you would get y equals a half and y equals a third, which ultimately will give you the answers that the question is asked you to find. Then moving on to 6AII, it says find all values of theta that solve the equation. So for this, we've already kind of done a bit of the hard work. So we know that cos theta equals a half and cos theta equals a third. Now if I do the inverse cos of both of those, then what we end up with is cos theta equals 60 and theta equals roughly 71, and that's to no decimal places. Then if I use the graph or use cast to work out what the other values are going to be within the range that I've got, so cos looks something like this. So the next angle for the where cos theta equals a half is going to be 300, and the next value for when it's 71 is going to be 289. So there are my angles for theta. Then moving on to 6b, it says hence find all the solutions for the equation, and here we've got 2 theta. Now because we've got 2 theta, what we now need to do is, if we go back to part AI, is we just need to extend this graph over another period and find the additional equation. So what we find then is that with cos 2 theta equals a half, then the answers are going to be for 2 theta are going to be 60, 300, 420 and 660. So that means then that theta is going to be half of those, so it's going to be 30, 150, 210 and 330. So that's one set of values we've got. Then when we've got cos 2 theta equals a third, then we end up with 2 theta equals, and again working with the decimals, we're going to have 70, we're going to have 290, we're going to end up with 430 and 650, which then gives us a theta value of 35, 145, 215 and 325. Now there may be some rounding issues, but again, as long as you're showing clear working out, then they should be absolutely fine. But generally speaking, to the nearest degree, you should end up with those 8 answers. Then moving on to question 7, it says that given that for all, where y is all for all real values, prove that 2 plus 3y to the power of 4 plus 2 minus 3y to the power of 4 is greater or equal to 32. And it's worth 6 marks, so a fine bit of a working out needed for this. Now, just to make the working out a little bit clearer, I'm just going to thin the pen so we can actually see what we're doing. So first things first, let's expand this out. So we've got 2 plus 3y to the power of 4. Now, depending on your method of presenting this using binomial expansion, it's entirely up to you. So you can feel free to use the one that I'm going to be using, or yours might be different. But as long as you're getting the correct expansion, it should be absolutely fine. So for this first one, it's going to be 4, 0, and then 2 to the power of 4, and then 3y to the power of 0. So that's my first term. Second term is going to be 4, 1, and then the first term with the power take away 1, and then the second power starts to increase, and then 4, 2, 2 to the power of 2, 3y squared, plus 4, 3, and then 2 to the power of 1, 3y to the power of 3, and then 4, 4, 2 to the power of 0, and 3y to the power of 4. So then working each of these out, so for this one I'm going to end up with 1 times 16 times 1. For the second one, I'm going to end up with 4 times 8 times 3y. For the third term, I'm going to end up with is 6 times 4 times 9y squared. Then I'm going to end up with is 4 times 2 times 27y cubed, plus, and then end up with 1 times 81y to the power of 4. Now, neating all of those up, I end up with 16 plus 96y plus 216y squared plus 216y cubed plus 81y to the power of 4. Now, I'm just going to keep that for now because that's just half the jumps. That's this one expanded. So now what I've got to do is expand this next one. So then we move on to, let me just keep that separate. So the next one we move on to is 2 plus 2 minus rather. 3y to the power of 4. Now if I expand that the exact same way, just to save a bit of time, I'll end up with 16 minus 96y plus 216y squared minus 216y cubed plus 81y to the power of 4. Then what I then need to do, oh, don't know why I've done that, so let me, it's this highlighter here that I wanted. So the next thing for me then to do is to then add those two things together. And so what I end up with is 2 plus 3y to the power of 4 plus 2 minus 3y to the power of 4 equals, and adding all of those together, I end up with 32 plus 432y squared plus 162y to the power of 4. Now, from this, because we're using for real values of y, that if y is greater or equal to 0, then y squared is going to be greater or equal to 0, and y to the power of 4 is going to be greater or equal to 0. So therefore, 2 plus 3y to the power of 4 plus 2 minus 3y to the power of 4 is going to be greater than 32 for all values of y. Then moving on to question 8, it says that proves that the curve with the equation of y equals 2x to the power of 5 plus 5x to the power of 4 plus 3x cubed minus 8 has one stationary point stating its coordinate. So for this, what we need to do is, first of all, just double check to make sure that the equation can't be simplified any further. So it's already written in terms of indices. So we can go straight into working out what dy over dx is going to be. Now I can do it straight off the bat. So that's going to be 10x to the power of 4 plus 20x to the power of 3 plus 30x squared, and then minus 8 just cancels. So then here at the stationary point, dy over dx equals 0. So then what I then want to do is just make this equal to 0. So I've got, let's use different colours. So I've got 10x to the power of 4 plus 20x cubed plus 30x squared equals 0. Then I can start cancelling things out by factorising, so I can get 10x squared out, and that then leaves me with x squared plus 2x plus 3 equals 0. So therefore either 10x squared equals 0, in which x equals 0, or x squared plus 2x plus 3 equals 0. Now if I then just go on and use the discriminants, so using discriminants, or you could use the quadratic formula, but either which way, make sure you're showing some working out. So if I use b squared minus 4ac and work that out, so that's going to be where a equals 1, b equals 2 and c equals 3, I work out that b squared minus 4ac is less than 0, so therefore no solutions. So therefore the only solution that I've got is where x equals 0. And then the last thing that I need to then do is state the coordinates. So here, when x equals 0, y equals, and again all I've got to do is then just substitute it in, which is just going to equal minus 8. So it equals minus 8, so then the coordinate is going to be 0, minus 8. Then moving on to question 9, it says that a curve cuts the x-axis at 2, 0 and has a gradient function of dy dx equals 24 over x cubed. Find the equation of the curve. So for this, first thing I'm going to do is I want to rewrite this equation using indices. So what I've got is I've got dy over dx is going to equal 24x to the power of minus 3. So then integrating this equation, I get y equals, and again increasing the power by 1 divided by a new power, I get 24 divided by minus 4, and it's going to be x to the power of minus 2. Then simplifying this, I get x equals, and it's going to be, well, that should be a 2, not a 4. Don't know where I've got 4 from. And divided by the new power. So then that then becomes minus 12x to the minus 2 plus c. Then if I then substitute the coordinates, so when x equals 2, y equals 0, then what I end up with is 0 minus equals minus 12, 2 to the power of minus 2 plus c. So c then comes up to give me an answer of 3. So then the equation of the original equation is going to be y equals, and it's going to be minus 12x to the minus 2 plus 3, or you could write it in fraction form where it's going to be y equals minus 12 over x squared plus 3. So any of those would be absolutely fine for the rather generous 4 marks. Then for B, it then says show that the perpendicular bisector of the line AB is the normal to the curve at 2, 0. So there's a couple of ways you can approach this. So let's first of all work with the perpendicular bisector of AB. So in order to do that, I need to find the midpoint of AB, in which the formula I use for that is going to be x1 plus x2 over 2, y1 plus y2 over 2. And using the equation, I should get a midpoint of -4, positive 2. If I then work out the gradient of AB, and that's using y2 minus y1 over x2 minus x1, then I get a gradient of AB as being -12 over -4, which gives me positive 3. So that therefore means that the gradient of the perp bisector is going to be the negative reciprocal, and that's going to be -1/3. So therefore then the equation of the perpendicular bisector of AB is going to equal y minus 2 equals -1/3 x plus 4. Then simplifying all of this, I get 3y minus 6 equals -x minus 4, and then just simplifying that, I get 3y plus x equals 2. Now the next thing for me then to do is to then work out what the equation of the normal in part A is going to be. So for this, the gradient at 2 at 2, 0. So then that's going to be dy over dx and x equals 2. So if I substitute 2 into my dy dx, which is given here, so it's 24 over x cubed. So that's going to be 24 over 2 cubed, which then gives me an answer of 3. Now this 3 value is the gradient of the tangent. So therefore the gradient of the normal is going to be the reciprocal of that, which is going to be -1/3. So then using 2, 0 and m equals -1/3, I get y minus 0 equals -1/3 x minus 2. Then doing a bit of rearranging, so here I get 3y equals -x plus 2, and then 3y plus x equals 2. And you can see that these two equations here are the same. And so there, I've answered the question. Then moving on to our last question, it says that on the 18th of March 2019, there were 12 hours of daylight in Inverness. On the 16th of June 2019, 90 days later, there were 18 hours of daylight in Inverness. Jude decides to model the number of hours of daylight in Inverness by n by the formula of n equals a plus b sine t, where t is the number of days after March the 18th, 2019. State the value that Jude should use for a. So if a is the initial value, so our initial value when t equals 0, so when t equals 0, because t is the number of days after the March the 18th, is going to be 12. So a equals 12. It then says state the value for that Jude should use for b. Well, this is going to be where t equals 90. So then here I end up with n equals, and we know that a equals 12, so that's going to be 12 plus b, and it's sine 90. Now we know that n equals, so when t equals 90, n equals 18. So we've got 18 equals 12 plus b sine 90. Now sine 90 is just 1. So here then we get a b value of 6. Then moving on to 10AII, it says using Jude's model, calculate the number of hours of daylight in Inverness on 15th of May 2019, 58 days after 18th of March. So this is when t equals 58. Now the formula for n is 12 plus 6 sine t. So substituting time 58 into this, we get n equals 12 plus 6 sine 58. And if I type that all into my calculator, I get an answer of 17.1, and that's to 1 decimal place. Moving on to part 4, it says using Jude's model, find out how many days during 2019 will have at least 17.4 hours of daylight in Inverness. So for this, what we've got is we've got 12 plus 6 sine t equals 17.4. Then if I do a bit of rearranging, I get sine t equals, and it's going to be 0.9. Then t equals the inverse sine of 0.9, which gives me an answer of 64.158. Then using the sine graph, I need to work out what the other values are going to be. So it's going to be 180, take away from 64.158, and that gives me 115.842. So then working out how many days there's going to be, well, it's from day 64 to day 116, which then gives me an answer around about 53 days. Now, if you think, well, hang on a second, 116 minus 64 is 52, but I actually need to include day 64. So because I'm not starting off, I'm starting with 64, that's my first number, then 65 onwards, so that gives me then 53 days. It then says explain why Jude's model will become inaccurate for 2020 and future years. And the reason for this is because Jude's model will repeat after 360 days, but don't know where I've wrote but with 2 T's, it's not that kind of but there are 365 days in a year. So something along those lines would be absolutely fine. Then for our final part, it says Anissa decides to model the number of hours of daylight in Inverness with the formula, and here we've got this, and the question saying explain why Anissa's model is better than Jude's model. Well, it's for the simple fact that it actually works for 365 days. So we just need to write because Anissa's model will repeat after 365 days, and because of the fraction, due to the fraction, which to be fair, you don't really need to add that, but it just cements what I'm actually writing.